Hello my scholars, welcome to my school YouTube channel. My name is Emmanuel and in today's video we'll be tackling JAMB CBT past question in chemistry for the year 2005. Please don't go nowhere, stick around and we'll be right back. You're welcome back to my school YouTube channel. In today's video, we'll be tackling question 1 to 25. Now let's get down to question number 1. Which of the following equimolar solutions will have the highest pH? When we talk about equimolar solution, it means all the solutions have equal or the same concentration. That's what we mean by equimolar. So considering that they all have the same concentration, the question is saying which one among this one has the highest pH. When we talk about pH, don't forget, pH has to do with what? The level of what? Negative logarithm of the hydrogen ion concentration or negative logarithm of the hydroxyl ion concentration, because we could have it for acid, we could have it for also alkaline solution. So let's look at option A. It says CH3COOH. Of course, this is your ethanoic acid, okay? For your ethanoic acid, you know this is a weak acid. And on a pH scale that has from 0 to what? To 14, let's look at the board. pH scale that has from 0 to 14, okay, we have at this point, which is neutral, that's the center. So from here to here, this is what? Acidity. So which means that as you move towards the center, as you move towards this point, the acidity actually what? It decreases. So if you move this way, it decreases. So which means that at this point, the strong acids, okay, strong acids will be towards 0, okay, they have low pH, while the weaker acids actually tends towards here, so which means they have higher values, okay. Weak acids have higher values, so you can have 6 here, you can have 1 here, okay. Strong acids have lesser value. Then as you move from the center to this point, we talk about what? Increase in what? Alkalinity. So which means after 7 values from, let's say, 8 to 14, they are alkaline solution, okay, alkalinity. So those ones that have, let's say, 8 here has a lesser pH to the one that have this. So we have the stronger ones will be here, okay, will be towards 14. The lesser one will be the weaker alkaline will be towards this one. This is what? Neutrality at that point. So when we talk about the first option, say CH3COO, ethanoic acid is a weak acid, so which means the pH should be something around here, around 4, 5, 6, tending towards 7, okay, because it's a weak acid. It does not dissociate completely when dissolved in water. The second option says sodium hydroxide. Sodium hydroxide is a strong acid, so which means that if we dissociate it in water, we have hydroxyl ion, okay, and then hydrogen ion completely dissociated. Sodium ion will be dissociated in water when it dissolves. So sodium hydroxide is a strong base, okay, it's a strong base. We'll talk about ethanoic acid first, being a weak acid, okay, weak acid, so it's going to have a value that is closer to 7, okay. Let's just assume, okay. Then we have the third option says HCl. HCl is what? Is a strong acid. HCl is strong acid because if you dissociate it in water, it dissociates completely, okay. And then, so which means strong acids we have values that are tending towards 0, okay, tending towards 1, towards that side. So which means their pH is actually low. For this one, pH is high, but it is still less than 7, okay. Strong acids should have values that are, you know, above 7, going 8, 9, 10 towards that side. So it's as higher one. That's for strong alkaline. Then ammonium hydroxide. Ammonium hydroxide is a weak base. Because it's a weak base, so the value is definitely going to be somewhere around 8, 9, just somewhere after the 7, okay. Then that means this strong acid definitely is going to have the highest pH among all of this one. So let's move back to the screen. Okay, this is a weak acid, this is a strong base, so strong base should have the highest pH value, okay. Then this is a strong acid, lesser, and then so among this now, the correct answer is option B, sodium hydroxide. Now to question number 2. Which of the following ions require the largest quantity of electricity for discharge at an electrode? Don't forget, of course, this is a topic under electrolysis, and usually when we talk about Faraday's first law of electrolysis, it starts to look at the relationship between the mass, okay, of a substance and then to the what? The quantity of electricity that will be passing through the substance that will be that will be electrolyzed, okay. So usually we know that 1 mole is actually equal to 1 Faraday. 1 mole equal to 1 Faraday. So at this point, if we have 4 moles here of chloride ion, this one undergoes, okay, let's look at the board. So don't forget that 1 mole is actually equal to 1 Faraday, okay, and 1 electron, okay, is equal to that. So if we have 4 moles, okay, of chloride ion, okay, normally if you have this, it should be that we have a 1 electron is actually, or we have a 1 negative. So we are going to multiply that number of electron by the number of moles here. 4 moles, okay, times 1 electron, okay, because we have just 1 electron here. If it loses that, so that's going to give us 4. So we have 4 what Faraday here. 4 moles of that, okay, so that's going to give us, the quantity of this will be 4 Faraday, of course, and you know that 1 Faraday is actually equals to 96,500. There's no point going through all those routes. So if not, you would have said 4 times 96,500, would have converted this one to be in coulomb. It's still in what? In quantity. So if we have option B says 3 moles, okay, 3 moles of sodium ion. Sodium ion is also going to have 1 electron. Okay, so we have 3 moles here, 3 moles times 1 electron, okay, because this is positive 1, okay, that is 1, so we have what, 3 Farad here, okay, that's the quantity. Then we have the third one, 2.5 moles, okay, of copper ion, okay, of course. By the time this one gets reduced, see what we talk about, look at it, copper ion, it's going to lose 2 electrons, okay, to eventually have what, be reduced to what, copper metal. That's what happens, okay. Copper ion is going to lose, okay, 2 electrons, is going to reduce, okay, by gaining 2 electrons, and then it becomes what, copper. So there's reduction because this is 2 plus, and then this is what, the oxidation state is 0. So reduction in, or decrease in oxidation state is reduction. So copper ion is reduced to copper metal here. So with what, 2 what, electrons, okay, unlike this place where we have 1 electron, 1 electron. So that's, we have 2.5 here now, multiplied by 2 electrons. Of course, that's going to give us 5 Farad. And the last option there is 2 moles, okay, of aluminium, okay. Of course, don't forget, aluminium becomes reduced, okay, gaining 3 electrons. Okay, it becomes reduced by gaining 3 electrons. Once it gains 3 electrons, what happens? It becomes aluminium metal. Okay, so it's no longer. So how many electrons we're giving up? That's 3 electrons, just like we have it here. So just multiply that 2 multiplied by the 3 electrons there. So we have 6 Faraday. So this as the question says, which one has the largest quantity of electricity to discharge? So of course, this is 6, 5, 3, 4. So it is 6F. 2 moles of aluminium, we have the largest quantity of what electricity. Let's move on to the screen. That's 6 Farad. That's 2 moles of aluminium give us that, which is D. So the correct answer is option D. Now let's move on to question number 3. Phenolphthalein in acidic solution is what? You agree with me that phenolphthalein is an indicator, okay? Something that shows a color change, okay? When that substance reacts with either an acid or a base, okay, is an indicator. We could have litmus paper, okay, could be a type of indicator. If you put in blue litmus paper into a solution and it turns red, it means it's an acid. If you dip your red litmus paper into a solution and it turns blue, it means it's base, okay, it's an alkaline solution, okay. So phenolphthalein is another indicator. We have methyl orange also. So the question says phenolphthalein in acidic solution is what? Usually if you had whether the drop, okay, if it's a solution of phenolphthalein, or you give it in powdery form, okay, usually in powdery form, okay, like, yes, if you had it, a pinch of it into an acidic solution, that solution is going to turn colorless, okay. If you add the same phenolphthalein into a base, okay, into an alkaline solution, you are going to have a pink coloration, okay. On the other hand, if it is methyl orange, if you add methyl orange into an acid, you are going to have a red color, okay. And then if you add the same methyl orange into a basic substance, you are going to have a yellow color. So let's look at the chart that you can always refer to in case you are confused. So you can see this table that shows these are the indicators we have here: methyl violet, thymol blue, methyl orange, chrysol green, methyl red, litmus, and so on and so forth. So these are the acid color. When they are introduced into the acid, these are the colors they give, and then for each of them, look at the base color. So if you look at methyl orange, like I said, red is what it gives in an acid, and then it gives a yellow coloration if you added it to a base. But we're asked for what? Phenolphthalein. Phenolphthalein is here, okay, in acidic solution, that is colorless. In basic solution, you have a pink coloration. So which means our answer is what? Colorless. So let's go back to our options so that we can pick the right answer. So we just saw that phenolphthalein acidic solution is actually colorless. So the correct answer is option C. Question number 4. When iron is exposed to moisture and it rusts, the value of change in G, of course, this is free energy, okay, for the reaction is what? First of all, we must analyze the reaction. What happens here? Yes, iron is exposed to moisture. What happens? It is a spontaneous reaction. The reason being that it does not need any external energy to drive that reaction. So on its own, the reaction is going what? To take place, okay? Does not, with the internal energy, that does not need an external energy. That's why we say it is what? Spontaneous reaction. And for every spontaneous reaction, though the reaction is slow, because it's a slow process, it doesn't take place. When we talk about rusting of iron, iron is exposed to air and water. What happens to moisture? What happens? It begins to what? Rust. And it's a gradual process, okay? So it's a slow process, but it's a spontaneous reaction. So, and for every spontaneous reaction, don't forget that your delta H, of course, there's going to be an increase in what? In delta S. Delta S is a what? Entropy. Level of disorderliness in that system is going to be increased at this point in time. And once it's increased, what happens? Invariably, delta G becomes negative because it is a spontaneous what? Reaction. So delta G is negative, delta H is negative, but delta S will be positive. So at this point now, we just go for our options. Delta G for the reaction is, because it's a spontaneous reaction, it does not require any external energy coming in. So spontaneous reaction, it means that what? Delta G must be what? Negative. Must be negative for every spontaneous reaction. Option A says neutral, B 0, positive, negative. So the correct answer is option D, negative. Now let's move on to question number 5. In which of the following reactions can the oxidation number of the nitrogen be said to have increased? Of course, this question was repeated, is repeated actually, because there was a year this same question was asked, okay? You need to know your level, your oxidation number very well, calculation, okay? That's going to help you here, because the question says, which one among these reactions now, okay, can the oxidation number of the nitrogen be said to have increased? Of course, if oxidation number is increasing from left to right, it means there is what? Oxidation. So in other words, the question is saying, where is oxidation taking place? So you need to calculate very well what to do. So for nitrogen, don't forget. So for this now, NO, of course, if you calculate the oxidation state of NO, nitrogen, NO here, okay, this should be equal to 0. Okay, so your nitrogen plus oxygen is actually negative 2, okay, minus 2 equals to 0. So N here is what? Minus 2 equal to 0. So which means nitrogen is what? Positive 2. So anytime we have NO, we already know that the oxidation state is what? Is plus 2. So we don't need to waste our time. So here is plus 2 at this point. So we are moving from plus 2 here. Don't forget where it is what? It is increasing, okay? And then we look at the right hand side where we have nitrogen here also. You try to calculate that. So NO2, okay, will be equal to 0 because this is a compound. So nitrogen, of course, this is minus 2. Minus 2 times 2, that will give us minus 4 equal to 0. So nitrogen is what? Positive 4. So of course, there's an increase here, okay? Just for benefit of doubt, once you have gotten it, because there's no way we'll have two options here, okay, that are right. We have already seen that this one is what? There's an increase from here to here. So just go for this. Option A is the answer. But for benefit of doubt, let's look at this, okay? Because you can have the question repeated, or you can see it coming another way where you don't know what to do. So NO, we already know this is what? Positive 2, okay? And then for this, NOCl. Now this is hypochlorite. If you separate this now, hypochlorite, okay? So it can serve as a radical. So radical is a group of atoms, okay, that act as a single unit. Of course, the charge is there. So if you have this, so it's like saying we have OCl minus. This is hypochlorite, okay? And usually chlorine in hypochlorite has a positive 1 as the oxidation number. Take note. Chlorine in hypochlorite has a positive what? 1. Hypohalide. Let me use halide now, because if you have it also in bromide like this, okay, bromine has oxidation state of positive 1. Okay, of course you can just try that. If you work this out, this equal to, of course, this is minus 1. Okay, so oxygen, okay, then we have, of course, oxygen is a minus 2. Then we have plus Cl. That's what we want to find, minus 1. So this is Cl will be minus 1. Move this, it becomes what? Plus 2. So Cl is what? Positive 1. So which means that chlorine or bromine in hypochlorite OCl or OBr is actually what? Positive 1. So if this is positive 1, so let's calculate if we have NOCl equal to 0. Nitrogen here, this is minus 2. Okay. And then chlorine here will be what? Will be positive 1 equal to 0. So this is minus 2 plus 1 will be minus 1 equal to 0. So nitrogen will be what? Will be what? Positive 1. So that means that this is what? Nitrogen here, oxidation state is plus 1. So plus 2 to plus 1, that is a what? A reduction. So this is not increase. Look at this also. You can calculate. This is already plus 2. So you need to calculate for this. If you calculate this one, of course, we are going to add this is minus 2. This side, I think you should also have plus 1 here. Yeah. And then at this point, you can calculate that. Okay, just for benefit that this is positive 2, then this one here, remember I would say bromide ion here in the hypobromide, OBr minus, hypobromide is also positive 1. So if you calculate that, you're going to have plus 1 here also. Okay, you can have, I didn't calculate this, okay, but let's not, because of time, we have already gotten what we needed. So which is option? So there's an increase only in option A here, positive 2 to positive 4. So the correct answer is option A. Let's move on to question number 6. We have 2 moles of hydrogen reacting with oxygen. In other words, burning in air. Okay, oxygen supports burning. So usually in reactions that involves chemistry, when we talk about air, we are talking about oxygen. Okay, so what H2, which is hydrogen, burns in air, reacts with oxygen to produce 2 moles of water. Okay, and then we have delta H, that is changing in enthalpy. Okay, internal energy is minus 571 kilojoules. So in the equation above, how much heat will be liberated if 12 grams of hydrogen is burnt in excess oxygen? First of all, we need to calculate what mass, okay, of hydrogen, because we're talking about hydrogen. So what mass of hydrogen produced this first? Okay, what mass of hydrogen produced minus 571 kilojoules of energy? Before we now calculate 12 grams of hydrogen, how many is good? I think it's just going to be a proportion, simple proportion kind of thing. So let's look at the board. We have 2 moles of hydrogen here. This is the reaction that is written again. Okay, so we said that number of moles, we want to calculate the mass, okay, that of hydrogen that actually gave us this hydrogen, that produced that hydrogen. So number of moles is mass over molar mass. Okay, we know that the number of moles here in this balanced equation is what? 2 here. So equals to mass is what we want to find, divided by the molar mass of hydrogen. Hydrogen has 1. So 1 times 2 here, because the atomic it is 2. So 2 times 2 will give 4. So in other words, we are saying 4 grams of hydrogen gas, okay, burns in air in excess oxygen, okay, to produce what amount of energy? That is what happens initially with this equation. We have what? Produce minus 571 kilojoules of energy. Okay, now we're asked to find what? 12 grams of what? Hydrogen. So we just write that here. 12 grams of hydrogen, okay, will burn in excess. Burn in excess. Okay, it's allowed. We can write it that way. In excess oxygen to produce what? Of course, produce what? X kilojoules, okay, of energy. So your simple proportion, by the time you have simple proportion, what I mean is simple proportion is 4 over 12 is equal to minus 571 here over x here. Just put them the way they are. So by the time you cross multiply, you'll be having 4x will be equal to 12 multiplied by negative 571. So which means x eventually will be 12 multiplied by negative 571 over 4. Okay, of course, 4 goes here, 1, 4 here, 3. So that will be 3 times negative 571. So by the time you multiply 3 by 7, by 1, that is 3. 7 times that's 21. That's 1 here, 2 here. 3 times 7, 5 is 15 plus 2, that's 17. So we have a negative sign. So minus negative 1713 kilojoules of mole will be produced by 12 grams of energy that is burned completely less. So let's look at the screen. 1713, that is this, 171, negative 1713 kilojoules. So the correct answer is option D. Question number 7 now. A concentrated solution containing hydrogen ion, copper 2 plus, copper ion, hydroxyl ion and chloride ion was electrolyzed using platinum electrodes. The ion that will be discharged at the cathode this is an aspect of electrochemistry, okay? Usually many students find it difficult solving questions on this, okay? We talk about the ones that are ions that are preferentially discharged, okay? Usually we said in the electrochemical series, those ones that actually are above, okay, the ions that are above the ones below, we have the power to be able to displace the other one. So one require lesser amount of energy to gain electron. Now we're looking at hydrogen ion, copper ion, or hydroxyl ion, and this. Those are the four we are looking at. Now the question says the ion that will be discharged at the cathode. Now usually there is an acronym I use. I use the acronym CARO. Okay, CARO, C-A-R-O, CARO. At least we have names of ladies that are CARO. Okay. It means C is what? At the cathode, reduction takes place at the cathode. At the anode, oxidation takes place at the anode. I say that again. At the cathode, reduction takes place at the cathode, and then at the anode, oxidation takes place. And don't forget that reduction is actually what? Reduction is what? Gain of electron, while oxidation is what? Oil. Okay, which is a what? Oxidation is loss of electron when it comes to in terms of electron loss. Now, so which means that at the cathode usually, the opposite charged electrons will migrate towards the opposite ones. In other words, a cathode is an electrode that is what? Negatively charged. Okay, cathode is an electrode that is negatively charged. Now it means that we need positively charged ion to move towards that negatively charged cathode. Anode are positively charged. So in other words, cations which are positively charged are the ones that will always migrate towards the cathode. Okay, that is negatively charged. Please get that correctly. Now what happens among these ions that are here? We have cations and we have anions. We have hydrogen ions and copper ions. Okay, these are these are the cations. Okay, while we have hydroxyl ion and chloride ion, which are the anions. So the cations that are positively charged will migrate towards the cathode. So in other words, now hydrogen ion and copper ion are the two possible ions that migrate towards the cathode, because the cathode is negatively charged, but the cations are positively charged ions. Okay, now we have established that fact. Now between these two, now which one is going to get discharged at the cathode? Now usually what we do is this. In the electrochemical series, we are looking at between these two now, which one require lesser amount of energy to be able to gain electrons. Don't forget, reduction takes place at the cathode. Reduction takes place at the cathode, and reduction is gain of electron. Both of them definitely has the tendency to gain electrons because they are positively charged. Okay, so they are cations moving toward cathode, so they have the ability to gain electrons, but one requires lesser amount of energy to do to be able to gain electrons. So between these two now, copper in the electrochemical series, okay, actually is below hydrogen. So which means copper is below hydrogen. Hydrogen is higher when you talk of in increasing order. Okay, is higher than copper. So which means hydrogen ion requires more energy, okay, to get reduced, okay, to hydrogen gas. Okay, this requires more energy to get reduced to hydrogen gas, okay, to gain electron to become reduced to hydrogen gas than copper ion. Copper ion requires lesser energy, okay, lesser amount of energy to be to get reduced to copper metal. Lesser amount of energy, it gains 2 electrons to become a copper metal. So between the two, we are looking at preference now. Which one has the tendency to require, it will absorb, it will take gain electrons with lesser amount of energy without stress? Is going to be copper compared to. So based on that, copper ion is going to get discharged at the cathode. Take note, copper ion requires lesser amount of energy to gain electrons, so it's going to take lesser amount of it, so it's going to get discharged actually at the cathode. So of course at the cathode, what happens? This is what happens at the cathode. We have copper ion, okay, it's going to gain 2 electrons to become reduced to copper metal. Okay, this is copper solid. This is what happens at the cathode. That's what we had to do here. So the correct answer is copper ion. Option A is the correct answer. Now question number 8. When sulfur 4 oxide is passed, of course that's your SO2, is passed into a solution of sodium hydroxide for a long time, it eventually produces a solution of what? Now you should be able to write your chemical reaction. If you can write it right or very well, you should have no problem. So this is sulfur 4 oxide is passed into a solution of sodium hydroxide. So we can have sulfur 4 oxide, that is your SO2. Okay, of course that's a gas reacting with your sodium hydroxide. Okay, so what happens here? We're going to have we have Na here. We have this. Okay, this is going to be, we are going to have Na with together with this SO, of course, SO3, of course. But don't forget that SO2 oxygen is coming here to make it XO2. So, but what happens? SO3 usually has 2 negative. Okay, that's it's a radical that has 2 ions. So, which means that the 2 will cross to this place. So this man should have 2 here. Okay, then we also have H2O should be formed here. So which means we can balance our equation now. Let's have 2 here. If we have 2 here, 2 becomes 2 sodium. 2 moles of sodium. Then SO, we have oxygen is 2 here, oxygen is 2 here. That's 2 plus 1, that's 3. Hydrogen is 2 here, hydrogen is 2 here. The equation is balanced now. So this is the product that we have, Na2SO3. So just look at the option here. Like I said, if you can write a balanced chemical equation, you'll be able to get this. Okay, that's what the examiner intends to achieve. To know if you actually know how to write a chemical equation, balanced chemical equation, stoichiometrically we balance, and then you see. So this is the option Na2SO3. So among this option now, Na2SO3 is here. So the correct answer is option B. Now let's move on to question number 9. What is the correct IUPAC name for NO2 negative? Okay, NO2 negative. So if we have NO2 here, we have NO2 negative. Okay, let's see what we can do. Let's calculate the oxidation number of what? Oxidation state of nitrogen here. So this will be NO2, because this is negative, -1. So we are going to equate this to -1. Okay, that's what the rule says. If this were to be, okay, a compound like this, a nuclear compound like this that does not have charge, this would have been equal to what? To 0. But because we have minus here, which is -1, so you equate it to what? -1. So nitrogen here, of course, oxygen is -2. That's the oxidation state. Valency -2 times 2 gives us -4, equal to -1. So N is equal to -1. Move this, it becomes +4. So N is actually equal to what? +3. So in other words, this is nitrogen 3. Okay, nitrate. But because it is what? This is what? We call this nitrate because it has it is a radical, so it bears that single name. It acts as a single unit, so nitrate. Okay, so nitrate 3. So now this is, we have option A says dioxonitrate 4. Dioxo means we have 2 moles of oxygen. Of course, it's present here. Dioxo, but nitrate, yes, 4. This is not 4. This is what? This is 3. So we should have Roman figure 3. So let's not waste our time. Let's just look for the one that have dioxonitrate 3 ion. It's ion because of this one, negative charge. So dioxo, triazono, both of them are what? Eliminated. So between this is not this option. This is dioxonitrate 3 ion. That is it there. So the correct answer is option D. Do you know you can actually take practice questions on our simulated JAMB CBT past questions? All you need to do is to click on the link in the description below that takes you to the Myschool website. There you'll be able to download the Myschool mobile app for your Androids and the Myschool software for your laptops and computers. Please go ahead and start practicing. Now let's look at question number 10. What will happen if an aluminum spoon is used to stir a solution of iron 2 triazonitrate 5? Actually, aluminum spoon, so which means the spoon is made of aluminum. Of course, there's going to be a reaction because iron is here and then we have aluminum. Aluminum in the electrochemical series is higher, okay? It's highly placed, so which means it's more reactive than iron. So in this kind of position, what happens? The aluminum will displace it, looking at iron as less powerful, okay? You see a boy that's, you know, it's bigger and then it's wanting to bully on a smaller one. It gets, come on, get off from that seat because it's bigger. That's what happens. Aluminum is powerful, it's more reactive than iron. So when it comes to this reaction, it's going to displace this iron and then it comes in there to become iron here. at this point to form triisonitrate 5. Okay, let's see what happens here. We'll have Al, okay, that's aluminium spoon, okay, it's made up of aluminium, then reacting with, let's see, yes, ion, we have Fe, triisonitrate, okay, triisonitrate 5, so this will be 2 here. So if this happens, what happens? We are going to have aluminum is going to displace this, okay, so we have Al, yeah. Then we have displacing this, so we have Na3, but because aluminum is 3 plus, so this will not be 2, this will be what will be 3 here. Okay, so what happens here? We have of course we have Fe here, this one becomes positive. You can balance the equation actually, okay, but our aim is that what we are going to have aluminium nitrate here will be formed because aluminum is going to what displace this. Please balance up the equation that we have there. So option A says the spoon will be oxidized while the ion 2 ions will be reduced to the metal. Is there oxidation taking place? This is plus 3 here to what? Plus here we have so minus 1, 3 here, that will be 0. So okay, so we have plus 3 to 0. So there's a reduction here, okay? So the spoon will be oxidized while the ion 2 ions will be reduced to the metal. Option B says the spoon will increase in size. It's not going to increase in size. The spoon will be reduced while the ion 2 ions will be oxidized. And option D says the spoon will be reduced. The spoon will not be reduced. Okay, so what happens is that what? Oxidation is what? There's an increase in oxidation number, while we have reduction where there's what? Reduce, where we have a deduction or decrease in oxidation number. So if you look at this one we have here, we have from plus 3 here, moving to, you can calculate the oxidation state of this here. This one is minus 1, minus times 3, that's minus 3 here. So we have it at this point. So there's the spoon will become oxidized, okay, while the ion 2 ions, okay, here will become what? Reduced to what? To its metal. You can see it here, sorry. We have this is Fe here, it's reduced here. We have 2 plus here. It's reducing to what? To become the ion metal here. Okay, there's a reduction here. So for this, that's solid. Okay, so here now, the solid spoon will be oxidized. When an aluminum spoon is used to stir a solution of ion 2 oxide, the spoon, because it's made up of aluminum, will become oxidized, okay, while the ion 2 ions will be reduced to what? To the metal. So the correct answer is option A. I hope you are enjoying this content. If yes, please don't forget to click on the like button, hit the subscribe button, and finally tap on the notification bell to keep you informed once we upload our next video. Now let's move on to question number 11. The enzymes responsible for converting sucrose into 2 simple isomeric sugars is what? Okay, we must understand that sucrose is a disaccharide. We have 2 monomers, okay, 2 monomers that make up that particular compound. We have so many disaccharides, but there are 3 common disaccharides, okay? Let me just take our time to just say it because you could have a question that will not require sucrose, okay? We have sucrose is 1. We have maltose is 1, okay, another disaccharide, and the third one that is very common is lactose, okay, that is your milk sugar, okay. For sucrose usually is made up of 1 molecule of glucose, okay, reacting with 1 molecule of fructose. Don't forget that both of them, this is C6H12O6, okay, and then what happens here? So we have sucrose, both of them are what? Monosaccharides. So 1 mole of glucose plus 1 mole of fructose is going to give us sucrose. Of course, that is your table sugar. The sugar you consume is from what? From sucrose, okay? We have it from sugarcane and so on. So we have maltose. Maltose is actually 2 moles of sucrose. 1 mole of sucrose reacting with another mole of sucrose, of glucose, okay? So 1 mole of glucose with 1 mole is going to give us maltose, okay? And then lactose is actually 1 mole of glucose, okay, reacting with what? 1 mole of galactose, okay? These are going to give us this. This is the milk sugar, the sugar that we have in the milk present. That's what lactose. But all of these ones now, they have enzymes. Enzymes are biocatalysts. Don't worry. Don't forget, they are proteinous in nature. They are specific in reaction. They are, they are easily denatured. You know what characteristics of what enzymes are actually, okay? So, and usually, how do you know that they are? They usually end with the name ASE, okay? So, for sucrose now, okay, the enzyme is called sucrase instead of sucrose. Sucrase, this host changes to A. Maltose becomes maltase, okay? And then lactose, the enzyme that breaks them down, is what we call the enzyme. Breaks it down, okay? Breaks mixed sugar down is called lactase, okay? But in these options, now if you look at these options, we have maltase. Maltase is for maltose, okay? It's the enzyme that breaks down maltose into glucose and glucose. Then aminase, okay? And then we have invertase, we have lactase here for that. So in other words, you don't have sucrase because we are talking of sucrose, but the other name in which sucrase is called invertase. So the examiner wishes to know if you actually know that sucrase is also referred to as invertase. So whether you see it as invertase or you see it as sucrase, we are saying the same thing. That's the enzyme that breaks sucrose into glucose and fructose, okay, to make up that. These are monomers, okay, to make up this disaccharide. Okay, so the correct answer among this now is invertase. Option C is the correct answer. Now let's move on to question number 12. The decolorization of purple color of tetraoxomanganate 7 ion is a test for what? Yes, usually when we bring in a solution okay, hydrocarbon for instance, and then want to react it with purple tetraoxomanganate 7 ion, okay, it is to test for the presence of unsaturated hydrocarbon. And when we talk about unsaturated hydrocarbon, it could be alkene or alkyne, okay? Don't forget that your alkanes are saturated hydrocarbon. Why are they saturated? Because they have carbon-carbon single bond, okay? That's why they are saturated. Like in this case, we can have 1, 2, 3, 1, 2, 3, okay? You have the bond that actually takes place between them is just one single. So carbon-carbon single bond, this makes it what? Saturated hydrocarbon, okay? But for unsaturated hydrocarbon, they have double bond, carbon-carbon. Okay, this hydrogen, just fix it there. Then we have carbon-carbon triple bond, okay? So we have hydrogen here. So for all of this ones now, okay, hydrogen. So the presence of this carbon-carbon single bond makes alkanes to be called saturated hydrocarbon. They are saturated, okay? The bonds are just there. So easily any attachment that can come in. That's why you see them undergoing what substitution reactions, okay? While in these ones now, we have addition reaction because there's need to break up this bond. They are unsaturated first. When a substance is coming to react, this bond will be broken to get attached, addition, okay, and then these bonds will be broken up. So these two are what? Unsaturated hydrocarbons. So to test for the presence of saturated carbon, once you bring purple color of tetraoxomanganate 7 into any of this, what happens is going to change the color of that, because don't forget that this is KMNO4. KMNO4 actually has a purple color. So once you bring in that substance into it, the color of that KMNO4 decolorizes. It no longer has that purple color again. So it means that, okay, that is an unsaturated hydrocarbon. If you look at all the reactions we have here, we have alkanes, of course. Alkanes are carbon-carbon double bond. That is unsaturated hydrocarbon. Alkanols are not unsaturated hydrocarbon. Alkanals are not, okay, that's your aldehyde. And then we have the alkanes. Alkanes are saturated hydrocarbon. So that's why we don't have this. So among this now, we have carbon-carbon double bond, which is alkane. So the correct answer here is option A. So which means anytime you react an alkene with a purple tetraoxomanganate 7, it could be ethene, it could be propene, it could be butene, it could be hexane, okay? We must have a decolorized. So it shows that that is presence of what. So the correct answer is option A. Question number 13. Which of the following are structural isomers? When we talk about structural isomers, we are looking at isomers, of course. Isomers are two or more compounds that have the same molecular formula, but they have different structural formula. When we say structural formula, spatial arrangement, okay? When you arrange them in the space, okay? How do they fare? Okay, how do they look alike? Structural isomers, okay? Which of the following are structural isomers? We have propanoic acid and propan 1,2. I think we just need to make use of the but, okay? So then we have propanoic acid and propan 1,2. So let's look at propanoic acid. Propanoic acid is we have CH3, okay? Propanoic acid, CH3, CH2, propanol. So that means we have 3 carbon atoms, propan, okay? Propanoic acid, this. So especially if you draw this, we have hydrogen, this is carbon, 1, 2, 3, 1, 2, 3, okay? So hydrogen here, hydrogen here, so this will be double bond oxygen, then we have oxygen, and then we have hydrogen, okay? That's the structure of propanoic acid. Then we have propan 1,2-diol. Propan 1,2-diol, we have propan 1,2-diol will be propan, that means we have 3 carbon atoms, 1, 2, 3, propan, okay, 1,2-diol. So that means we have diol. We have 2 OH group on carbon 1 and carbon 2. 1, 2. 1, 2, diol. So that means we have hydrogen here, hydrogen, 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 hydrogen here, 1, 2, then we have hydrogen here. So this is propan, 1, 2, 3, propan, 1, carbon 1, 2, diol, 2 diol, that is propan, 1, 2 ol. So option B says propanal and propanol. Propanal we have 1, 2, 3, that's 3 carbon atom propanal. So we are going to have hydrogen here, hydrogen, hydrogen here, hydrogen, hydrogen, then propanal. So we have okay, HO, we can just have this there. So this is propanal because of this what? HO, that's an aldehyde, okay, propanal. Alkanal, okay, that's what it looks like. That's propanal. Then if you draw the other one, propanone. Propanone has 1, 2, 3. Okay, we could have hydrogen here, hydrogen here, hydrogen here. Double bond oxygen can be here. We have hydrogen here, hydrogen here, hydrogen here. 1, 2, 3, 4. Okay, so that's what it is. So this is a propanone here. This is propanol. Then ethanoic acid and propanoic acid. Ethanoic acid, we have CH3. I think let's just write this. CH3. Okay, ethanoic, okay, CH3COH, okay, that's ethanoic acid. Then propanoic acid, we have CH3CO, okay, CH3CH2COOH, okay, that's propanoic acid. Then ethan 1,2-diol, ethan 1,2-diol, that means we have 1 ethan 1,2-diol, so we have carbon 1, 2, that's 2 carbon atom, 1, 2-diol, so we have OH here. We have OH here, okay? We have H here, 1, 2, 3, okay? Diol. Then the other one is ethanoic acid. Ethanoic acid is CH3COOH, okay? Now, don't forget, we're talking about structural. When you draw it, it's looking at structure, but don't forget that the number of carbon atoms must be the same for the two of them because they're isomers. The number of oxygen must be the same. Then the number of hydrogen must be. Let's look at this one. Carbon is 1, 2, 3. 3 carbon atoms. 1, 2, 3, 4, 5, 6. Okay, we have hydrogen is 6, then oxygen is actually 2 here. Let's look at this. Carbon is 1, 2, 3, that is C3. Okay, H here is 1, 2, 3, 4, 5, 6, 7, 8. This is 8, and then oxygen is 2 here, O2. Of course, this one is hydrogen is 8 here, hydrogen is 6 here. Okay, 1, 2, 3, 4, 5, 6. So this and this cannot be isomers. Okay, let's look at the second option. We have carbon 1, 2, 3, we have C3. How many hydrogen? 1, 2, 3, 4, 5, 6. Hydrogen is 6, and oxygen, we have just 1 oxygen. Let's look at this. Carbon 1, 2, 3, we have 3 carbon atoms. Hydrogen, we have 1, 2, 3, 4, 5, 6. 6 here. Then we have 1 oxygen here. Of course, these are two of them, they have the same molecular formula here. Okay, though their structures are not the same. So, but the number of these, the isomers, the molecular formula must be the same. These are, let's look at this. We have 1, 2, we have C2, H4, and then we have O2 here. Then let's look at this. This is carbon is 1, 2, 3, C3, H, this is 5, okay, 3, that's 5, 6. There's no point wasting time here because already this is 4 hydrogen here. Then the carbon is 3, this carbon is just 2 here. Okay, let's see this, this is 2. Okay, and then for this we have carbon here is 1, 2, carbon is 2, hydrogen is, we have 1, 2, 3, 4, 5, 6, 6, then oxygen is 2 here. Then let's look at this. Carbon is 2, hydrogen is 4 here, oxygen is 2 here, okay? Yeah, so if you look at this now, these ones are not, okay? This one cannot be said to be isomers, okay? Yes, even though it is ratio 1 is to 2 is to 1, ratio 1 is to 2 is to 1, yes, they are having the same functional group here, but they are not isomer because isomer, the definition for isomer says that what? They must have the same molecular formula, okay, but their structural formula definitely might be different, okay? So among all of this one now, C3H this and this is what we have there. So the only difference is what? Their structural formula, but they have the same number of molecular formula. So based on that, option B happens to be the answer. Let's move on to the screen. So we have propanal and propanone. So propanal and propanone actually are said to be isomers of each other. So the correct answer is option B. Now let's move on to question 14. In the purification of impure samples of ethyl ethanoids, of course that's an ester, okay? through the process of esterification. Synthesized by esterification, concentrated sodium triisocarbonate 4 solution is used to remove what? We have option A is to remove water, option B basic impurities, option C acidic impurities, option D we have ethoxyl ethane. Yes, actually we know that we are talking about purification, so which means there's what? There are impurities there. Okay, so if there are impurities there, so option A can be stricken off. We strike that off because it's not an impurity. Yes, in this context, because we are talking of esterification. Alkanol react with alkanoic acid to give what? Alkanoate and water. Okay, of course the reverse reaction is an hydrolysis reaction. Okay, so but we are talking about purification of impure samples. So when we have a sample that is impure, okay, so what happens there? We want to remove that impurity. But so which means option A is not it, even though it's one of the products of esterification. Option B say ethoxyl ethane. No, it is not that, because we don't have that as one of the. So we have basic impurities, acidic impurities. These are the two impurities that we have there. So now let's look at what is going to be used to remove what. So we have esterification, concentrated what? Sodium triisocarbonate 4 solution is used to remove. So the question is, sodium triisocarbonate 4, what type of solution is it? Is it an acid or is it a basic solution? Of course, this is a basic solution. So a basic solution is not going to remove a basic impurity. A basic solution is going to remove what? An acidic what? Impurity. Okay, so because neutralization has to take place so that you can get the salts form and then the water is eventually what? Formed also, so that we can have that. So neutralization to take place. So sodium triisocarbonate 4 solution is a basic what? Solution. So it needs to what? To remove what? The acidic impurity. So based on that now, the acidic impurities, the correct answer is option C. Question 15. How many hydrogen atoms does a single ring cycloalkane have less than the corresponding open chain alkane? When we say open chain, we are talking about the straight chain alkane. So we'll just give an example so that we can buttress our point and then we can achieve, because it says how many hydrogen atoms does a single ring cycloalkane. Now when we talk about cycloalkane, that means we have an alkane, okay, an hydrocarbon in what? In a cyclic form. In cyclic form. Okay, so cycloalkane, let's use propane, like to cyclo, okay, let's use cyclo, they always have that name with them, cyclo. Let's use cyclopropane, okay, with their corresponding open chain. So which means propane has 3 carbon atoms. So the corresponding open chain, straight chain, will be propane. They will not be cycloalkane. So we have propane here, okay. So let's draw this one. Cyclopropane. We have 3 carbon atoms. 1, 2, 3 in cyclic form. Okay, so let's draw now. We have carbon here. Don't forget the rule. Carbon cannot take more than 4 bonds. Okay, 4 bonds usually. So for this carbon atom, we have 1, 2, 3, and 4. Okay, for this carbon atom, we have 1, 2, 3, and 4. Okay, for this carbon atom, 1, 2, 3, and 4. Okay, so let's draw for propane now. Propane is still what? 3 carbon atoms. 1, 2, 3. But this one is what? Open chain. It's a straight chain. It is not a cyclic like this. So let's draw this now. The same rule is being observed. Carbon will not take more than what? 4 bonds. Okay, so we have, for this carbon atom, we have 1, 2, 3, and 4. For this carbon atom, we have 1 here, we have 2, 3, and 4. That this carbon atom we have attached to this carbon 1, 2, 3, 4. For this carbon atom, we have 1, we have 2, we have 3, we have 4. Okay, so let's count now. The number of carbon atoms we have here: 1, 2, 3. So we have C3. For this 1, 2, 3, C3. So they are the same. But the question says how many hydrogen atoms? So let's count. Hydrogen 1, 2, 3, 4, 5, 6. So we have 6 hydrogen atoms here. Let's count these hydrogen atoms. We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 hydrogen atoms here. So this is 8 atoms of hydrogen, 6 atoms of hydrogen. So what's the difference? 8 minus 6, that's what? That's 2. So by 2, now this one now, goes beyond these two here. So the question says, how many hydrogen atoms does a single ring cycloalkane have less than the corresponding oxygen open chain alkane? We said 2. So option A is 2, 3, 4. So the option A says 2. So the correct answer is option A. Question number 16. Equal moles of ethyne and hydrogen iodide react to give what? Okay, we have this, we have this. So ethyne, of course, we know that is C2H2, yeah, reacting with hydrogen halide, okay, that is halohalide HI to give what? So usually to help us understand this and all this, let's draw the structure of this. So that's going to be, because it's ethyne, so that is what? Carbon-carbon triple bond, because it's an alkyne. So we have carbon-carbon triple bond, 1, 2, 3, okay? Then we have 2 hydrogens, so which means this hydrogen is here, this hydrogen is here. So we have, don't forget, this carbon has 1, 2, 3, 4. This carbon has 1, 2, 3, 4. So carbon must always take 4 bonds, okay? And then we have plus hydrogen ion is coming in there, okay? So what happens? We're going to have, now this hydrogen here and ion, both of them are coming on addition reaction. What happens? For this hydrogen ion, hydrogen halide or hydrogen iodide to come in here, now the rule says that this bond, the first bond, we have 3 bonds here, must be open. Once this bond open, this one comes in to attach here. So what happens? This hydrogen will come to this carbon, attach here, then this hydrogen will what? We attach to the what? To this what? This iodine, this carbon that is here. But don't forget that this bond is already open, so we are left with what? 2 bonds here. Okay, so we have carbon, double bond here will be formed here. So we have this hydrogen here bonds with this carbon, but don't forget there was hydrogen here before. Then this carbon atom we have here, we have hydrogen here before, so the iodine or iodide is coming here to this place. So this is what we're going to have as a product. So we can rewrite this as CH2 here. Then we have double bond here. We have carbon. Then we have what? HI. Okay, HI. This is what we have here. So this is what we got from food. So we can look at the options. We have CH2 double bond carbon CHI. This is CH2 CH2. This is just your. That's just your alkane. No, that's not what we have. CH2 CHI, but double bond, not single bond. This is single bond. This is double bond. Yes, carbon CH2 CHI. So the correct answer here is option D. Now let's move on to question 17. A substance that is used as a ripening agent for fruits is what? Of course, this you can also find this in biology questions oftentimes. Okay, the substance, okay, is an alkene. Okay, an alkene. Okay, particular alkene that's responsible for ripening of fruits. When you get fruits that are not ripe yet, your mango, your mango, yes, your cashew, some of the fruits that are not ripened yet, they spray those chemicals. If you spray it on them, what happens? It begins to ripen, okay, within the shortest period of time. That is ethylene. Ethylene is the substance. It is the substance that is used to ripen fruit. Ethylene, okay. In other words, it's that you call it ethylene or you call it ethene. It's the same thing. Ethene or ethylene, not ethane, okay. I'm saying propane here, saying methane here, saying butane. No, it's not any of this, okay. It's ethene. So in some cases you might not see ethene, you might see ethylene. It's the same thing. Ethylene, ethene is the same. So ethene is the substance that is used as a ripening agent for food. So the correct answer is option A. Now let's move on to question number 18. When water boilers are used for a long period of time, the solid substances left behind as scale are what? Don't forget, when we talk about water boilers, of course we have the common one like the boiling rings, okay. Nowadays we don't see them so commonly, okay, used now, okay, maybe because of the level of electricity that it consumes, the current consumes. So but we have the boilers, okay, boiling ring, just have it there. So if you use it over the years for so long a time, what happens? You discover that you begin to find some substances, maybe some white substances around the rings, okay, or you have it getting rust because it is actually what's coming in contact with water and air, which is what is responsible for what? For rusting to take place, okay. So the question says when water boils, and what is that indication? It shows that what? The water is hard. Not just what type of hardness, it is temporary hardness, because that is the type of hardness that can be cured, okay, by what? by boiling. When you boil water that is temporarily hard, what happens? It becomes to what? We have some furors, okay, that are furing of kettles. We have those rings that are those white substances, those brownish colored substances that are formed around the kettles or the boilers, the boiling rings, okay. And then what is the answer? It shows that what there's the presence of what? Calcium ion. Of course, most times it could be calcium, hydrogen, triisocarbonate 5, okay, or 4, or we could have a magnesium triisocarbonate. So we have magnesium and calcium ions, okay, of triisocarbonates, okay. From that, then we could have silicates also, because we have some sand substances that is there in water, so we could have triisosilicate also being formed with it. And what's this? So the question says, when water boilers are used for long period of time, the solid substances left behind as scale are what? Option A says magnesium triisosilicate 4 and rust. Definitely rust must be there, because this is a substance, a metallic substance that is coming in contact, exposed to air, okay, and what? Moisture. So rusting will be left behind, rust. And then we have magnesium triisosilicate. Yes, more likely, because we have magnesium triiso, okay, carbonate, okay, would have been, but in this case we have silicate because we have silicon dioxide as the sand, so we can react to form magnesium triisosilicate 4 and rust. Yes, we can have this left behind. Let's look at the other options. Option B says magnesium triisosilicate 4. Yes, we can have that. And calcium tetraososulfate what? 6. No, this will nullify that, because calcium tetrasulfate 6 has to do with what? Permanent hardness. And permanent hardness is not going to get solved by boiling the water. So you will not form it, have it precipitating there. So this permanent hardness makes this not to be correct. Option C says clay and magnesium tetraososulfate 6. Of course, we are seeing tetraososulfate 6 again coming in there. This is what? A permanent what? As a result of permanent hardness. And this is for you to boil the water to have this come. That means we have the precipitates of that is insoluble. It means that what? It is what? A temporary hardness. So this is also correct. Clay and rust. So rust is fine, but clay is not. So among these options now, magnesium triisosilicate 4 and rust happens to be the best, okay, solids that will be what? That will be left behind as scales in the water. So the correct answer is option A. Now question 19. 25 cm3 of a mixture of noble gases was obtained from air after the removal of other constituents. What was the original volume of air? Don't forget that air is a mixture of gases, okay? We dealt so much on that in one of our video lessons in chemistry, okay? So please, you can subscribe for better understanding for our video lessons in chemistry, so you can see when we talked about separation techniques, we talk about air, okay, as a mixture of gases, okay? So we discovered that the air, being a mixture of gases, it has various compositions, substances that make up, compounds that make up that air. We have nitrogen there, nitrogen having about 78%, okay, in total composition. We have oxygen having about 21%, okay, of the composition of air. And then we have oxides of carbon. We have your carbon dioxide. We have impurities there, okay, in form of noble gases. Noble gases actually has 1%, okay, 1%. Of course, we have about 0.934 as the argon, amount of argon that is in that noble gas. So argon make up a larger percentage in the total percent of what? Composition of noble gases. In other words, what we are saying is that noble gases has 1%, okay, of the total percentage value of what? Of the volume of air that we have there. So now that we know that, we're told that 25 cm3 of a mixture of noble gases was obtained from air after the removal of other constituents. So what's the original? So I would just want to say that the mixture of air, volume of, okay, let's just use the board, okay, let's use the board so that it can be clearer, okay. So I would just say we have the volume of mixture of noble gases, mixture of noble gases will be equal to what? We have percentage, okay? We have percentage composition of the noble gases itself, okay? Noble gases itself in air as the mixture, okay, in air as a mixture, multiplied by what? 100 over 1. Of course, this is what we call, okay, no, that should be, this is percentage already. Composition of noble gases is going to be multiplied by what? The total volume of air itself. Total volume of the mixture of air. Okay, so we have that. So if you use this formula, volume of mixture of noble gases was already given to be 25, so we have this to be 25 cm cube. So we have 25 cm cube here, equal to, what is the percentage composition of noble gases in air? We said it is 1%, so we just have 1% here, then multiplied by the total volume of air. We do not know that, and that was why the examiner says, what was the original volume of air? So we just say total volume, we can say VT, total volume of air. Okay, we can just simplify that. So this is 25 will be equal to 1% means 1 over 100 multiplied by V subscript T. Okay, so if we have that simplified, that we have 25 equals to 1 times V subscript T, we have VT over 100. Okay, so we have this over 1. When you cross multiply 1 times VT, we have VT will be equal to 25 times 100. So V subscript T should be 2,500 volume. So that should be in cm cube, okay, of air. So the total volume of air was actually 2,500 cm cube. Out of this, 1% of this, of course, is what? The noble gases, which is what? 25 cm cube. Of course, 1% of 2,500 is going to give us 25 cm cube. So the total volume of air is actually 2,500. Let's move on to the screen to see what we have as the options. Option A says 2,500 cm cube. Option B says 12580. So the correct answer is 2,500 cm cube. The correct answer is option A. If you have any question on all we have done so far, please feel free to ask. All you need to do is to click on the link in the description below that takes you to the Myschool website. There, you'll be able to ask a question and solutions will be provided within the shortest period of time. Now, let's move on to question number 20. The solubility curve shows the variation of solute concentration with what? We have volume, we have temperature, vapor density, pressure. Of course, the answer is temperature. If you plot a graph, usually on the y-axis, we have concentration, okay, of the substance, that the solute, okay, that will be what? That will be dissolved, and eventually we have what? Temperature, because temperature is dependent on what? The type of what? The type of concentration, the solute, the way the solute is going to get dissolved in it. Don't forget, solubility has to do with the amount of solutes that get dissolved in what? 1 dl cube of what? Of solvent, which could be water or any other solvent. So it is temperature dependent. So usually the curve is usually between the concentration of the solute, and then on the y-axis we have what? Temperature alongside with it. So the correct answer is option B. Do you have better steps or better explanations on all we have done so far? Please feel free to share with us. All you need to do is to go to the comment section, indicate the question number and the solution you would like to share with us. Now let's move on to question number 21. The air around smelting industries is likely to contain what? When we talk about smelting industry, we are talking about smelting process has to do with the application of heat, okay, to an ore or chemical reducing agent, usually to get the desired products, okay, that we have to wear. So it involves heat application and chemical, okay, to reduce that. So in areas like that, what happens? What kind of air do we have? Now we need to know what process actually takes place there. Now, first we have what we call the reducing agents, okay, that is involved in the reaction. Now when we talk about reduction, before we talk about reducing agents, we have to roast first the ore, okay. The ore will be roasted first with heat. You heat it, you roast it, and when you are roasting it now, you are roasting the sulfides ore, the ores of sulfide, okay, the ores of sulfur. So sulfide ores are usually what are roasted. Once that is roasted, what happens? Sulfur oxide is given off as gas, okay, is generated because there's roasting first. Once you roast it, you bring in the sulfide of sulfide ores, the ores of the sulfide, then to roast. Once you roast, before the smelting process actually what takes place. So SO2, sulfur oxide, is actually what produced, generated in that form. So already we have SO2. Now during the roasting, the smelting process, now we need a reducing agent, okay, to reduce the ion, to reduce the whether it is zinc, whether it is whatever substance that needs to be smelted, okay, so that want to get the desired product, we bring in a reducing agent, and the reducing agent usually that we bring in there is the fossil fuel. And you know, fossil fuel has high content of what? Of carbon. So carbon will react with oxygen that is from the ore, okay. Carbon from the fossil fuel will react with oxygen that is from the ore to produce carbon monoxide, and eventually we can have it producing what? Carbon dioxide into the what? Atmosphere. Don't forget, the air around there will be forming that. And then we don't forget that to drive home that smelting require what? Something to generate electricity. We need electricity to drive that, okay. We call it fuel. We call it fuel cells, okay. Fuel cells. And what is used as the fuel cell is actually hydrogen. So hydrogen is used as the first fuel cells in the smelting process. So in that sense, we can say that we also have, of course, hydrogen gas will also be in the air based on what we are using. Fossil fuel, carbon dioxide is coming as a result of what? The fossil fuel as a reducing agent. Then this one is coming because we need to roast it first, okay. Roasting of the sulfide ores to form what? SO2 will be generated, and then from the what? Fuel cells that we need to drive that to generate electricity, we need hydrogen. We already be what? Generated also. So we have SO2, CO2, and H2. So let's look at the options. We have H2S, no, that's not it. We have CO2, SO3, yes, no, not SO3. We don't have SO3, we have SO2 here, so this is not correct. We have H2 hydrogen, we have SO2 here, we have CO2, yes, that's correct. We have SO2, N2, and of course, we have nitrogen is present in the air, we know that, okay, because it has a larger percentage in the air, okay, but that, don't forget, around the smelting what? Industries, that's what we're looking at. So among these options now, hydrogen, SO2, and C is the correct answer. So the correct option here is option C. Now let's move on to question number 22. Kerosene is commonly used to remove the red color stain of palm oil from clothes because it's what? Option A says helps to spread the oil over a larger surface area. If it's going to help to spread the oil over a larger surface area, then it's not going to remove the stain of that palm oil. So option A is eliminated. Option B says react with the oil to form an odorless compound. The odor has nothing to do with the stain, to remove the stain, okay? We're talking of what makes it to remove the red color stain. So if it removes odor, what happens to what we can see, okay? Odor and what we see does not have any correlation. So option B is also eliminated. Option C says makes the oil evaporate easily by dissolving it. Yeah, because kerosene is actually a solvent, yes, so it can dissolve. It can dissolve that oil that we have, the red colored stain of the palm oil that we have on that clothes. Yes, if you bring it in, it does that by what? Evaporating it. Yes, that is more likely. But let's look at option D first. Option D says helps to dilute the oil and reduce its color. If it dilutes the oil, we're still going to have the stain there, okay? The concentration might be reduced, but it doesn't remove it and reducing the color by that. So, which means that it has the tendency to remove the stains, the red color stains of palm oil from clothes because it makes the oil evaporate easily by dissolving it, because it's a solvent, okay? That is why it has the power to turn that. So, the correct answer is option C. Let's move on to question number 23. The gas that is the most dangerous pollutant to human is what? We have option A says sulfur dioxide, that's SO2. Actually, we know that the gas that is most dangerous, okay, pollutant to human is carbon monoxide, that is CO, because it's what we call the poisonous gas, okay? From the generators, from exhaust, we get them, and that's why it's always advisable that you don't on your gen and then you put the exhaust close to the room, because when you have more of that, it gets into the system and then goes to attack the respiratory system, according to the blood. It blocks where the iron is, and then oxygen will not be able to get into where the hemoglobin should attach to. So once it gets in there, then the oxygen cannot come in when the CO is already blocking that point. So you have to person suffocates and dies. So carbon monoxide is the most. But if you look at this option intentionally, the examiner did not include carbon monoxide, carbon dioxide, because he knows that almost everyone knows that CO, which is carbon dioxide or carbon monoxide, is the most. So we have sulfur dioxide here, we have carbon dioxide, we have nitrogen oxide, we have hydrogen sulfide here. So among all of this one now, we have carbon dioxide. Carbon dioxide is not, because we breathe in oxygen, we breathe out carbon dioxide. So if we are breathing out carbon dioxide, it's actually in us. So if it is in us, if it is the most dangerous, then that means we should die because it's in us already. So we are expecting, so this is not. Nitrogen oxide also is not. That we have between the, so I eliminate option B and C. So we have sulfur oxide and hydrogen sulfide. Yeah, both sulfur oxide and hydrogen sulfide are compounds of sulfur. Okay, so sulfur oxide, which is your SO2, and hydrogen sulfide actually happen to be the more dangerous pollutant. So let me say the most among these four now. The most, sulfur oxide and hydrogen sulfide. Okay, usually both of them have what? The tendency to what? To pose threats, okay? Poisonous threat, okay, to humans, okay, when we inhale them, SO2 and H2S. Okay, but between the two of them, one of them is the most, because we are talking about the most dangerous. The most dangerous is what? Hydrogen sulfide. I will tell you why. Now, this is why. Hydrogen sulfide usually has a lethal effect on human respiratory system. If it is inhaled, okay, it has a lasting effect, of course, and rapid, just like almost like what the carbon 2 monoxide or carbon monoxide will do, okay, to respiratory system. And not just attacking the respiratory system, it also attracts the CNS, okay, in biology we say CNS, that's central nervous system, also is affected by this hydrogen sulfide. Of course, this also has effect, but this one has more effect than this in humans, so on human health, okay? So because of that, both of them, like I said, why both of them actually are dangerous, are more dangerous to what? To human health, okay? Hydrogen sulfide actually is a better option compared to what? Sulfur oxide, SO2. So based on that, the correct answer is option D, hydrogen sulfide. Now we are proceeding to question number 24 now. Natural water collected from rivers and ponds contain oxygen, carbon dioxide, and what? We have nitrogen, we have hydrogen, we have chlorine, we have sulfur, we have oxide. Of course, if we have chlorine, there is going to go there to kill those oxygens that we have there. But we're talking about natural water that is collected from rivers and ponds. Okay, we have sulfur, we have oxide, okay, we have hydrogen, we have chlorine, we have sulfur, we have, so nitrogen, let's look at nitrogen. Nitrogen, yes, is actually very essential, okay, to aquatic organisms that we have. Aquatic organisms, we have nitrogen. Yes, nitrogen should be one of the other substances, okay, that will be present in it, because we have nitrogen present in water in form of ammonia. Yes, in form of ammonia, in form of nitrites, in form of nitrates, okay, we have them nitrogen present. Of course, your ammonia is NH3, okay, nitrogen is there, that is present in the water. We have nitrites, okay, we have the nitrates too, okay, nitrates, we have nitrites, we have NO2, we have NO3, we have nitrogen present in that. So, and how does nitrogen get into this? When rain falls, we are talking about natural water collected. So when rain falls, we can have nitrogen present in it. When we have movement of water, so we have nitrogen present more in it, in the what? In the water, and that is what? That is natural water that's collected from rivers and ponds, because we have ammonia, more of ammonia here in this. Nitrogen is actually required by aquatic organisms to what? To survive, okay, to carry out their metabolic activities more than any other of these ones that we have here. So based on that, the correct answer is option A, nitrogen. Now let's move on to question number 25. How many moles of limestone will be required to produce 5.6 grams of calcium oxide? Okay, we have calcium is having a mass of 40, carbon is 12, oxygen is 16. I think we need to move to the board so we can demonstrate and see what to do when we are faced with such kind of questions. The question says how many moles of limestone will be required. So first of all, if you don't know what the formula of limestone is, then that means you might not be able to solve this question, okay? So, which means, of course, if you have been following us by now, I believe you should know what the formula of limestone is actually. That is your what? Calcium carbonate. Calcium carbonate, for short, we call it calcium triisocarbonate 4, okay? So, calcium carbonate, okay, to produce that. So, which means if we have calcium carbonate here, CaCO3, that's the limestone, okay, reacting to give this. So which means if you react this, maybe you dissolve this or you react with that, then we have CaO here. Of course, this is a carbonate. Maybe you bring in an acid to show this or to react with this. We are going to have this, and then we have CO2. Yeah, CO2, because this is a carbonate. So CO2 will be given off. So let's see, carbon 1 mole, calcium is 1, oxygen is 2 plus 1, 3. So the equation actually is balanced. Okay, calcium oxide reacting with this, we have CO2 there. So if this, how many moles of limestone will be required to produce 5.6 grams of this? So there are two ways. Like I used to say, there are different ways of killing a rat. So whichever method is more preferable, okay, and easier for you, you can just follow. Okay, so the first one, the question says how many moles of limestone, which is this, how many moles? First of all, this is ratio 1 is to what? Is to 1. So which means, because we have, when you balance this stoichiometrically, this is 1 mole, okay, of calcium carbonate will produce 1 mole of this. So but the question says how many moles of nice limestone will be required to produce 5.6 grams of calcium oxide? So 5.6. So I will just write here 5.6 grams. But we want to get what? The number of moles. So I will say that number of moles is equal to mass. Of course, this is solid. To calculate number of moles, mass over what? Molar mass. By now, I think you should be familiar with this formula. Number of moles equals to mass over what? Molar mass. Okay, so already we know what our mass is to be 5.6, but do you know what molar mass is of calcium oxide? So you can calculate that. Molar mass of calcium oxide is actually equal to, calcium is what? 40, mass is always given, is there? Okay, plus oxygen is what? 16. So which means this is what? 56 grams per mole. Okay, 56 grams per mole. That is the molar mass of calcium oxide. So 56. So now we said this is number of moles is equal to mass over molar mass. So which means number of moles will be equal to mass is 5.6. We have 5.6 all over. Of course, we have molar mass now to be 56. So you can solve this. 5.6 over 56. We don't need the calculator to run this. Let's see. We move this 1.1 decimal point once, so that it becomes 56 now all over. We move this once, so we had 1 0 to this because we moved it once. So that is 560. So 56 here 1, 56 here 1, then we have 0. So this is 1 over 10. Of course, if you solve that, that gives us 0.1 mole. 0.1 mole of calcium oxide was produced. But don't forget, because 1 mole, the ratio is 1 mole of calcium carbonate produces 1 mole of calcium oxide. So if 0.1 mole of calcium oxide now is formed, then that means we are also going to have 0.1 mole of calcium carbonate will produce what? 0.1 mole of calcium oxide. So the answer is what? 0.1 mole. Alternatively, like I said, we can also use this method to say that, okay, this is, we calculate the molar mass of this, the mass of calcium carbonate. So we'll say, of course, that's 100. I know that, okay, but let's calculate it together. Calcium carbonate will be equal to, okay, please don't forget I said alternatively. So we are done with this. So if this other method suits you or you prefer this alternatively, okay, now molar mass of calcium carbonate will be equal to, calcium is 40 plus carbon is 12 plus oxygen is 16. Okay, we have 3 moles of that. Okay, so that will be equal to 40 plus 12, that's 52. 52 plus 16 times 3, that should give us 48. 52 plus 48, that should give us 100. So this is 100 grams per mole. That's the molar mass of what? Calcium carbonate. Another way you can say the mass of it is 100 grams. So what we are saying now is this. Now, if we want to look at the relationship now, this produced this. So if 100, we've calculated the molar mass of that. If 100 grams of calcium carbonate produced, then the molar mass of this also will be 40. We have done that before. 40 plus 16, that's 56. We did that here. So if 100 grams of calcium carbonate produces 56 grams of calcium hydroxide, okay, what is the mass of calcium carbonate that will produce what? We're given 5.6, okay? 5.6 of this. So this will be 5.6 gram calcium oxide. So by the time you cross multiply, we'll be having X will be equal to 5.6 times 100 divided by what? 56, okay? So let's move this once. That's 56. We had 0 here. So that's 56 times 100 over 560. So 56 here, 1 here, 1, 0 cancels 0 here. So that is 10. So we have 10 gram of calcium carbonate. Okay. So 10 grams. So the mass of calcium carbonate now is what? 10 gram. So what is the what? The molar mass of calcium carbonate. We said that is what? 100 gram per mole. We did that before. We solved that here. So we can say number of moles. The question says find what? How many moles? So number of moles will be mass over molar mass, which is equal to the mass is actually 10 gram over molar mass is what? 100. So 0 cancels 0. We are left with 1 over 10. So that will be what? 0.1 mole calcium carbonate. Okay. So we have solved it in two different ways now. Either you come through this route, okay, by calculating 5.6 gram, calculating the number of moles for this, then you look at the what? The mole ratio of the two of them. If this one is 1 mole, so this is 0.1, this will be 0.1 also. For this, you go through this, calculate the molar mass of calcium carbonate, calculate molar mass of calcium oxide. So you juxtapose them side by side. If 100 gram of calcium carbonate produces 56 gram of that, what mass of calcium carbonate will produce for 5.6? Then you have this. Then this is your mass over molar mass. You get this. Whichever way you still get the answer. Now let's move on to the screen now. 0.10 mole. Okay. Option A says 0.2. Option B says 0.10 mole. So the correct answer here is actually option B, 0.10 mole. I believe you enjoyed this content because I really did solving those questions. If yes, please don't forget to click on the like button, hit the subscribe button, and finally tap on the notification bell to keep you informed once we upload our next video.